The scene is set in a bustling medieval village, free of modern technology. This historical context highlights the importance of traditional skills. The village showcases a variety of activities essential for daily life in this era. Manual labor involves performing tasks primarily using physical effort and skill. It often requires specialized knowledge and dexterity to manipulate tools and materials effectively. These skills are essential for construction, crafting, food preparation, and textile production. The scene showcases a split-screen comparison between a medieval technique and its modern counterpart. Examples include a hand-built stone wall versus a concrete wall, or a hand-forged tool versus a mass-produced one. This comparison visually demonstrates the enduring value and effectiveness of traditional skills. A small village rests in the valley's embrace, smoke curling from chimneys painting a scene of rustic tranquility. The camera focuses on a humble dwelling, its sturdy build a testament to simple life and quiet endurance. Sunlight bathes the well-maintained home, promising warmth and tales within its walls. In the dim medieval home, Ilara meticulously prepares char cloth, her brow furrowed in concentration. She carefully places linen in a sealed pot, setting it over the low fire, a crucial task underway. The sparsely furnished room centers around the fire pit, the heart of Ilara's focused work. Around the fire pit, Ilara, Thomas, and Mia huddle together against the encroaching cold, their faces etched with a shared hope. Thomas strikes flint against steel, sparks flying in the dim light, a desperate attempt to conjure life from the unyielding stone. Life from stone and cloth, Thomas says as the small flame dances, its warmth a fragile promise against the night. Lightly charring wood causes a surface transformation. This process closes the wood's pores, forming a protective layer. The sealed surface reduces moisture penetration and decay susceptibility. Charring significantly enhances wood's resistance to environmental factors. The carbonized layer acts as a protective barrier against insects, water, and rot. This barrier deters insects, prevents water absorption, and inhibits fungal growth. Charring techniques were historically applied to medieval structures for wood preservation. These charred structures have exhibited remarkable longevity, lasting for centuries. This demonstrates the effectiveness of charring as a long-term wood preservation method. Mortise and tenon joint is formed by inserting a projecting tenon into a precisely cut mortise. This design creates a strong connection by distributing force across a large surface area within the wood. Accurate fitting is essential to ensure the joint's strength and overall stability. The assembly process starts with aligning the tenon precisely with the mortise. The tenon is then carefully inserted into the mortise, sometimes requiring gentle force. The joint is secured with pegs or wedges, which expand to lock the components tightly. Mortise and tenon joints distribute stress throughout their entire structure. This contrasts with nailed joints, where stress concentrates around the nail shafts. The broad contact area of mortise and tenon joints ensures long-term structural integrity. A stone bench is placed directly next to a traditional hearth. Heat radiates from the lit hearth and comes into direct contact with the stone bench surface. The stone material absorbs the thermal energy, causing its temperature to gradually increase. The stone bench absorbs heat as the fire burns. The temperature of the stone increases, storing thermal energy. The bench functions as a thermal battery, retaining the fire's heat. Stone materials can store heat effectively. The stored heat is gradually released into the surrounding environment. This makes stone benches effective as passive heating systems. Root cellars are commonly constructed underground to utilize the Earth's natural insulation properties. The surrounding soil provides a stable temperature environment, shielding food from temperature extremes. Effective construction requires digging deep enough to reach consistent ground temperatures, typically several feet below the surface. Root cellars preserve produce through consistent cool temperatures and high humidity. Coolness reduces microorganism activity, slowing decay. High humidity prevents produce from drying out, extending shelf life. Root cellars are designed for the long-term storage of vegetables during colder months. They maintain stable conditions to prevent freezing and rotting. This method ensures a supply of fresh produce when outdoor growing is not possible. Salting preserves meat by extracting moisture through osmosis. Salt creates a hypertonic environment, drawing water out of meat cells. Dehydration inhibits bacterial growth and enzymatic activity, preventing spoilage. Smoking preserves meat using drying, heating, and antimicrobial deposition. Smoke contains phenols that kill bacteria and slow oxidation, acting as preservatives. Heat from the smoke dries the meat's surface, inhibiting microbial growth. Drying preserves meat by lowering its water content, inhibiting microbial growth. Exposure to dry air causes surface moisture to evaporate, creating an unfavorable environment for bacteria and fungi. This process concentrates flavors and extends the meat's shelf life significantly. A pot-in-pot refrigerator utilizes a smaller clay pot nested inside a larger one. The gap between the two pots is filled with sand, which is then saturated with water. This simple setup leverages evaporative cooling to preserve food. Evaporation occurs as water transforms from a liquid to a gaseous state. This phase transition requires heat energy, which is absorbed from the surroundings. The absorption of heat leads to a cooling effect, reducing the temperature of the immediate environment. The temperature inside the inner pot is significantly lower than the outside ambient temperature. This temperature difference preserves food longer than room temperature storage. The pot-in-pot refrigerator provides an effective, electricity-free method of food preservation. Precise log shaping is essential for nailless construction. Logs must be carefully crafted to ensure a perfect fit with adjacent logs. Techniques like scribing, notching, and saddle cutting ensure tight interlocking and even weight distribution. The assembly process involves stacking shaped logs in a specific sequence. Each log's weight and surface friction contribute to the wall's stability. The cumulative effect of these forces ensures the structure remains intact. Nailless log home design requires careful consideration of weight distribution and structural integrity. Overhanging eaves are essential to protect the logs from moisture damage. The building's layout must ensure balanced forces to maintain long-term stability and prevent structural failure. Natural springs served as primary water sources for communities. Villagers located and accessed these springs for their water needs. Spring water was valued for its purity and accessibility. Villagers construct pipes by carving hollow conduits from tree trunks. Hand tools are used to shape the wooden segments with precision. These segments are then joined to form a continuous pipe for fluid transport. Wooden pipes were buried underground to protect them from damage and temperature fluctuations. The pipes were strategically sloped downwards to utilize gravity for water transport. This system efficiently carried water from the spring towards the village, supplying homes and mills. Lime plaster served as a common building material in medieval times. It was used as an alternative to modern cement. The plaster consists of lime, sand, and water, forming a porous structure that allows it to breathe. Lime plaster allows moisture vapor to permeate through walls. Unlike impermeable cement, lime plaster absorbs moisture when present, preventing it from being trapped. It releases absorbed moisture back into the air as humidity decreases, aiding in moisture regulation. Lime plaster's breathability helps prevent mold growth by allowing moisture to escape. This moisture regulation also reduces the risk of structural decay in buildings. These properties contribute to the longevity, durability, and sustainability of lime plaster and construction. Hand forging starts with heating iron in a forge to achieve malleability. The blacksmith then uses a hammer and anvil to shape the heated metal. Precise, controlled hammer blows gradually form the desired tool shape. Hand-forged tools typically possess greater durability than modern factory-made tools. The forging process aligns the metal's grain structure, enhancing its overall strength. This alignment increases the tool's resistance to wear and tear over extended use. Well-maintained, hand-forged tools can endure for generations. Blacksmiths invest skill and care, resulting in effective tools. These tools become heirlooms, embodying craftsmanship and durability. Timber yards store massive wooden beams, essential for traditional construction. Workers meticulously inspect each timber for quality and correct dimensions. Precise measurements and quality control are vital in timber framing. The process involves raising a large timber beam using ropes and manual labor. Workers coordinate their efforts, pulling ropes in unison to lift the beam. Teamwork and physical exertion are required to raise heavy timbers without machines. Traditional timber frame structures demonstrate enduring architectural technique. These structures, like cathedrals and great halls, showcase the durability of timber framing. Their longevity exemplifies the skill and craftsmanship of historical builders. Bread was a fundamental component of the medieval diet. Its availability and quality were critical factors in daily life. This was especially true for the peasant population, for whom bread was a primary source of sustenance. Medieval bakers utilized several methods for baking, reflecting limited technology. These methods included baking on heated stones, in clay ovens, or under hot embers. Achieving the right texture and flavor required careful temperature and timing control. Slow fermentation was a key aspect of medieval bread making. Extended fermentation enhanced the bread's nutritional value and flavor. Enzymatic reactions broke down starches, releasing essential nutrients and creating a more digestible product. Charcoal production was historically essential for cooking and heating. It also powered blacksmith forges, making it a crucial energy source. The high demand for charcoal drove the development of specific manufacturing techniques. Wood is tightly packed into a pit to control the burning process. The pit is sealed with clay and earth to limit oxygen exposure. Limited oxygen prevents the wood from burning completely into ash, producing charcoal. Charcoal production involves slowly heating wood in a sealed pit over several days. This heating process causes pyrolysis, converting wood to charcoal by removing water, methane, and tar. The resulting charcoal burns hotter and cleaner than raw wood due to its higher carbon content and fewer impurities. Medieval villages commonly featured small gardens dedicated to herb cultivation. These gardens provided a local source of medicinal plants for the community. The herbs were integral to the village's healthcare practices. Mint was a popular remedy for stomach ailments in traditional village life. Villagers prepared mint infusions or teas to relieve digestive discomfort. Willow bark was used as a natural pain reliever due to its salicylic acid content. Lavender was traditionally used to promote sleep and relaxation. Villagers placed lavender sprigs near beds or used lavender-infused oils. This created a calming environment conducive to rest, forming a practical medical tradition. Raw wool is initially obtained directly after shearing from sheep. The raw wool then undergoes a cleaning process to eliminate dirt and debris. This cleaning typically involves washing the wool in warm water and teasing apart the fibers to prepare it for spinning. Cleaned wool fibers are spun into thread using a spindle. The spinner drafts the wool, twisting fibers to form a continuous strand. The spindle is twirled to add twist, winding the spun yarn onto it. A spinning wheel is an alternative tool used to spin wool into yarn. The wheel rotates a flyer and bobbin, drawing out and twisting wool fibers. This process is more efficient than using a spindle, producing yarn ready for textile crafts. Sunlight bathes a quiet village, casting long shadows. The air is still, the scene peaceful. A small wooden house stands nestled among the trees, a beacon of warmth in the tranquil landscape. The rhythmic clacking of a loom echoes softly, a comforting sound in the otherwise silent village. Inside the weaver's hut, Elara, an elderly woman, sits at her wooden loom, her experienced hands deftly weaving threads. Her weathered hands create an intricate pattern, sweat beading on her brow as she concentrates under the dim light. Elara pauses, her critical eye examining the weaving, ensuring each thread meets her exacting standards. Elara lifts the finished cloth from the loom, her eyes lingering on its intricate design in the soft light. Lyra enters, her eyes widening at the sight of the fabric. Lyra smiles, offering the treasure. Lyra's fingers explore the soft weave, Each thread tells a story, Lyra. Remember that. Raw animal hides undergo preparation for tanning. The hides are cleaned and soaked to eliminate impurities. This cleaning process ensures effective penetration of tanning agents, improving the final product quality. Cleaned hides are submerged in vats of natural tanning solutions. The soaking process can take several months for tannins to bind to the hide's proteins. This extended duration is essential for durable and flexible leather. Tanned leather is processed into finished goods such as shoes, belts, and bags. These products highlight the durability and flexibility resulting from traditional tanning methods. The meticulous tanning process ensures the longevity of these leather goods. Traditional fishing often employs woven fish traps in shallow water. These traps are strategically positioned to capitalize on fish behavior. The design guides fish into an enclosed space, facilitating capture. Fish traps are designed with an easily accessible entrance. The trap's design makes it difficult for fish to locate the exit once inside. This one-way design ensures fish remain trapped within the structure. Sustainable fishing practices prioritize the long-term health of fish populations and aquatic ecosystems. These methods have been employed for centuries, with minimal negative impact. This low-impact approach ensures responsible harvesting of food resources from aquatic environments. Dried reeds are the primary material used for thatching roofs. The reeds are sorted and prepared to ensure their suitability for roofing. Drying and bundling the reeds makes them lightweight and durable for roofing applications. Roof thatching involves layering reeds on a roof structure. Each layer is carefully placed and secured to build the thatch roof section by section. Proper overlap ensures weather resistance, creating a dense and insulating barrier. A completed thatch roof offers both aesthetic appeal and practical advantages. A well-maintained thatch roof can last approximately 40 to 50 years. Thatch provides excellent insulation and natural weather protection, emphasizing longevity and sustainability. Medieval carpenters commonly produced natural glue from animal hides and bones. These animal-derived materials are rich in collagen. Processing collagen transforms it into a strong, natural adhesive. Animal glue is created by boiling animal hides and bones in water for a long time. This process extracts collagen from the materials. The extracted collagen is then concentrated into a gelatinous glue, which is applied hot and sets as it cools. Furniture made centuries ago with natural glue still exists today. This demonstrates the glue's remarkable durability and bonding strength over time. The longevity of naturally glued furniture highlights the effectiveness of traditional adhesives. Candle making begins with raw materials such as rendered tallow and natural beeswax. Essential tools include a dipping vat for coating wicks and a heat source to melt the wax. Prepared wicks, typically made of natural fibers, are central to the candle's structure and burning. The candle making process starts with repeatedly dipping a wick into melted tallow or beeswax. Each dip adds a layer of wax, which then cools and hardens. Multiple layers gradually build up the candle's form, determining its final shape and size. The completed candle is now solid and ready for illumination purposes. Once lit, the candle provides a warm and soft light. Candles were a practical and essential light source before electricity. Water wheel harnesses the kinetic energy of flowing water. The wheel's rotation converts water power into mechanical energy via a central shaft. This mechanical energy can then be utilized to power machinery, such as millstones. Millstones use a stationary and a rotating stone to grind grain. Grain is fed between the stones for processing. The slow grinding preserves nutrients, yielding healthier flour. The water's flow provides the energy to turn the mill wheel. The rotating wheel drives the stones to grind grain into flour. This process exemplifies a sustainable method of food production, integrating technology and nature. Traditional skills represent a lifestyle centered on dedication and meticulous labor. Craftsmanship prioritizes superior quality and lasting durability in every creation. This approach cultivates a strong bond between the artisan and their work, contrasting with mass production. Traditional methods promote community through shared knowledge and collaboration. Modern work environments can often be isolating, reducing social interaction. Traditional practices build social bonds and mutual support within communities. Traditional methods often exceed modern shortcuts in key areas. These advantages include superior quality and greater longevity. Traditional practices also often have a lower environmental impact.